Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And I'm Kaitlyn. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. And for an email, you can contact dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, Kaitlyn, where do you attend school and what grade are you in?
I attend Warren Junior High, and I'm currently in 8th grade.
Are you done with 8th grade? Like you ready to
much.
move on?
Yeah, pretty much.
It's not even the end of the first quarter. You're ready to move on already.
Yeah, I'm ready.
Yeah, there you go. So, what kind of math are you doing right now in 8th grade?
I believe we're in like Algebra 1 area, pre-algebra, that kind of.
And you like that?
Yeah, it's pretty fun.
What did you do last year in 7th grade? Do you remember kind of some of the things you did, some of the topics you did?
We did do some of like inequalities, like pre-algebra, more pre-algebra. I think this year might be more Algebra 1-ish stuff.
Okay. So do you have an idea of what math course you'll be taking as a freshman next year? Or have you not even gotten to that thing yet?
So over the summer, I'll be doing geometry, meaning that I will go into my freshman year doing Algebra 2.
Good. And you like that idea?
Yeah.
You like doing math?
Yeah.
You know that math is going to provide a lot of opportunities for you down the road.
Most likely.
Yeah. The more math you know, the easier things
would be.
Right. I mean, because imagine if you struggled all the time with it and you needed some help, which would be fine.
Yeah.
But the more math you know, probably the more opportunities will be available for you possibly. And do you have an idea what you might want to do when you're through with school?
I wanted to be like a neonatal doctor.
Okay.
And
do you still want to do that, or is it something else been added to that?
I just want to work kind of in with younger kids and babies in that sense, in the doctoring field.
Okay, good.
In that way.
So you've got a direction.
Yeah.
Good. You ready to do a little bit of math?
Sure.
All right, let's take a look at the social media problem of the day. So we can take a look up at that monitor right here. So it says, find the area. We have a lighter and a darker shaded figure up there. So what would be the first thing you would do with this problem?
So it's two different shapes in which you cannot multiply certain numbers to get the whole thing as a whole. You have to split the figure into two sections. And it's already split with a lighter shade color and then darker shade.
So that's a pretty good way to distinguish between the two, because if they were all one solid color, it might be a little more difficult, right? Because there would be different possibilities to cut it into, right?
Yeah.
All right, so what do you want to do first?
So first we could find the area of the lighter shaded area.
Okay.
And that would be 4 times 3. Because it's length times width to find the area.
Gotcha.
So that would be 12. And then you could do the darker shaded rectangle, and that'd be 5 times 8, and that's 40. So that would be 40 plus 12 to find the full area, and that'd be 52.
You're sure of that?
Yeah.
Okay, so let's go back. On the right-hand side, it says 3 inches. What would that whole length be down that side?
8.
And how do you know that?
Because you can assume that if one side of the rectangle is 5 inches, then the other side will be the same.
So if I'm saying that the right-hand side is 8,
yes,
and the bottom is 8,
yes,
if I filled in that empty spot, wouldn't it be an 8 by 8?
yeah,
Which would be what?
64.
Okay, and then I could subtract the empty space.
And that would be 4 and 3
Okay.
again.
Right.
Yeah.
So I would have 64 and subtract the 12, and then what would I get?
52?
52, the same thing you got the first time, right?
Yeah.
So I just wanted to present that in case some students look at it and go, well, instead of adding both of the things, maybe I just solidify the whole thing and take that one part away. Does that make sense?
Mm-hmm.
So are you willing to go with B, 52 square inches?
Yeah.
You sure?
Mm-hmm.
You feeling pretty good about it?
Yeah.
If you don't get it right, do you think you should go on in 8th grade? I'm only kidding. You'll go on in
If I
8th grade.
don't
I'm
get it right.
All right, let's take a look and see how she
Confident.
did. Did she get B? Yeah, I knew you'd get that one. See that? First one done, just like that. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. If you happen to call today and we do your math problem on air, you will receive a couple of tickets to the Kern County Fair, and that will be going on all throughout, I believe it ends this Sunday, coming up October 1st. I think that's the date, right? So this Sunday. So you've got, it'd be hard for you to get the tickets tonight, but you would be able to go Wednesday, Thursday, Friday, Saturday, or Sunday. So all you have to do is call in. We do one of your math problems. You're going to the fair for free. Time now for today's Math in the News. All right, today's Math in the News, pretty exciting. Usually we have a guest on during Math in the News, but today we've got two guests on Math in the News. We've got Scott Schaefer from San Jose State University and Constance Woodman from Texas A&M University. Welcome to both of you.
Thank you for having us.
So you guys have been working together, even though you're not physically in the same spots, on this project with bird eggs, correct?
Mm-hmm.
And
yep, that's right.
more specifically, I know there are different types of bird eggs, but one that kind of struck our attention when we saw the article was about condor eggs, correct?
Mm-hmm. Yeah.
All right. So Scott, we're going to kind of start with you right now, and correct me if I'm wrong, and I very well may be here, but I just want to give a quick synopsis of what you guys do. So condors and other birds that are endangered, you're looking to help their population by manipulating eggs so that they make more eggs. Is that kind of in a quick capsule, kind of what's going on?
Sure. Yeah. I mean, the basic idea is to understand how the birds are caring for the eggs in the wild, and then use that information to better take care of eggs in an artificial situation.
So what you did is you've come up with a way where you've taken one of the eggs of whatever type of bird it is at the time, and you are constructing an egg to simulate the actual egg that would have been in the nest, correct?
Yep. So you probably have seen how your smartphone will change its orientation because it has a little sensor inside that changes the screen. And so I worked with some engineers to create an egg logger that records once per second. So that's 86,400 samples per day. And it's telling me every time the bird is changing its egg orientation.
Now, you have to make sure that these things are like exact, because we can see the orientation right now of how this thing is moving around the way it would in the natural setting.
Yeah.
But you need to make sure that the size, the mass, everything, I mean, even colors probably also, right?
Yes. Yeah. And so we generally try to measure a number of different eggs from the same species and get a good idea of the size and the shape, and then look at the color. And usually I work with Connie on having her design the eggs and print them for me on her 3D printer.
Okay, so Connie, you get this information that Scott has collected, and you're taking it to the next step, correct?
Yeah, there's two things that we do. One is Scott creates the computer program that allows us to read the data. And then the other thing we can do is we can take the data from the loggers and we create mathematical models. And that tells us what the most important parts of the environment are to produce healthy baby birds. So I will construct these 3D models of the egg and these special structures to hold the sensors that come from Scott's lab. but then we collect that data and we use that data in a mathematical context to help the animals.
Right, and I know that we've got some graphics here also. So some of the tools that you're using and what you're doing. So are you guys able to see these also at the same time?
Yes.
Okay.
So in the picture on the left, you can see a picture of the egg with a light below it, and it's picking up the blood vessels inside. And part of the reason why birds turn their eggs is because they need to redistribute the heat that the parent is providing to the egg in the developing embryo. And so by turning it, it allows the heat to be moved around more evenly. And it also helps the developing embryo. And in the bottom right picture there, you can see some eggs that I removed from the nests, placed them in an incubator while I put one of my egg data loggers in the nest for the bird to incubate. And then after 4 or 5 days, I swap them back and give them back their real egg.
So I've got so Scott, is this always just one egg at a time, or are there any birds that have more than one egg?
Yeah, it's common for many species to have more than one egg. I primarily focused my research on seabirds, and a lot of seabird species typically lay one egg. And so in that situation, I would take the egg out and put it in an incubator.
And
so
how
albatrosses, like shown here, is one of those species.
Okay, so how long is this process? So you take the egg out. How long is it until it is ready to
go? Well, usually I leave the egg logger in the nest for some of those species up to 3-4 weeks. It just depends on the battery. But many of the species, like that albatross, will incubate its egg for 60 days, so 2 months.
Okay, so let's scroll down. We can see what's inside of an egg right now. So we can see the SD card, the logger. And I was reading something where you need to make sure that you dyed them certain colors, because otherwise it would be a glowing effect kind of with the egg, correct?
Yeah, so that's where Connie actually puts her magic on the eggs, and I'll let her explain that.
The parents will look at several factors in the eggs to choose whether or not the egg is worth sitting on, and one of them is color. And so we use a little bit of chemistry to understand what kinds of colors will be safe for the birds to touch and what kinds of plastics will be safe for the birds to touch. And we take that data and we use that to inform how we build the eggshell and how we color the egg. So in the case of the eggs for the California Condor project, we took them and boiled them briefly in a non-toxic dye used for children's clothing.
All right, so perfect. So you're using what a kid would have next to their skin for these birds. I've got a question for you, because you're making these things just like the actual bird eggs. Are there times during the incubation where the parent bird would kind of feel the egg and movement inside of the bird? Is that something that you're able to simulate also? Does that make sense?
Not
what I'm
exactly.
asking you right there?
Yeah. So as the developing embryo gets older, they do move around, and in fact they start to produce their own body heat. So the egg or the chick inside relies less on the heat that is being given by the parent. But that's usually as the chick gets older inside the egg and before it's getting ready to hatch. But they move around. They try to orient themselves, and the parent orients themselves as the chick is approaching hatch.
Okay, so both of you have been working collaboratively on this. Connie, how successful has this been so far with you guys doing this?
I've been really happy with the results. We were very lucky that a collaborator, Celine, in Europe, had some data that was needed in an emergency by a rare duck breeding group that was trying to get a type of eider duck to hatch. And so we were lucky that there are enough people using these egg loggers now where the kind of data the rare duck group needed was available on demand from Celine's group in Europe. And we were able to give them the information they needed to make better choices to help the baby ducks. So I think it's very successful, and we've been able to work in Latin America, North America, Oceania, Europe. It's been really cool so far.
Good. So you've been able to travel a little bit with this also. So as far as egg fertility, and we know that the condor is one of the birds you're going more sought to help with it.
Yeah, so we've worked with a couple different species, condors being one of them, but there's another species in Uzbekistan, the Asian bustard, that is also endangered, and placing the loggers in the nest was able to provide more information about how the parents are taking care of the eggs, and that information can inform captive breeding programs so that the eggs can be more cared for or mimic the information that they would receive in the wild.
And we've got some footage right now of is this candling is what the proper term for this?
Yeah, Connie, you can probably take this one since it's your video.
Yeah, so what we're seeing right here, is about 15 species of birds in an incubator. And an incubator is an artificial way to keep an egg warm, humid, moved, rolling, and to change the airflow over the egg. And the reason we want to put the eggs in the incubator is when we manipulate the wild nest, we can change the reproduction rate. If we pull the eggs from a mother bird, she may have another set of eggs afterwards called a clutch. And if she double clutches, that's twice the number of baby birds. And for very rare animals, it's really important to get as much expansion of that population as possible. And so if the conservation workers have that first clutch of eggs in their hands, they need to take care of it. And you can't just put any kind of bird egg in a chicken incubator. You have to have the right settings for the species. We're able to help create better settings by bringing in the data. For example, I've changed the incubator settings I use for great green macaws based on the data we got from adult great green macaw hens. And those are a critically endangered species.
Okay, and I think that's a great point in case somebody's, some students are watching going, all right, well, you just put them in any chicken incubator and this thing is going to work. But as you just said, there are different temperatures that all of these things need. Now, how long, what got you guys going on this project in the first place? Was there something that you like, hey, let's start doing this logging?
Well, for me specifically, I do a lot of research in the field, and I've had a lot of time to watch birds sit on their eggs, but I really haven't looked closely at how often they turn their eggs, how they actually turn their eggs. And in some situations, you have birds that are nesting underground or up in a tree, and you can't actually see what they're doing. And so the only way to get that information is by using a logger that you can place in the nest and have it record for you.
Okay, so one final thing, Connie, if somebody found what you guys do rather fascinating and interesting, and they go, I am into birds and I would like to do something like this, are there certain courses or areas of study that a student coming out of high school would need to focus on to go into a field like this?
I would strongly suggest statistical modeling. All of our data goes through computer math programs that help us produce outcomes to inform what we do and read the data. I would also suggest field courses where you go out and you see the real world and you balance access to the real world, such as a field course in Costa Rica or Mexico or Southern California, against the time spent in the computer and with the book. Because if you put the book and the computer learning together with the real world learning, you're able to use your learning to influence the real world beyond just the computer study.
Yeah, well said. I think being out there and actually doing things is going to be the biggest thing for a lot of the students also, and see if that's actually what they want to do, because as you said, you were going to spend a lot of time outdoors. As Scott said, he's out, looking at these birds and studying them all the time. Just fascinating stuff, though. We caught that article, and it was very interesting, and the math you guys do behind it, very helpful for our students, and just the whole field of helping the endangered species that you are. So, Scott, Constance, thank you very much for taking time with us today.
My pleasure.
All right, that is today's Math in the News. Do remember we have phone tutors available until 5:30 on most Tuesdays and Wednesdays. In studio with us, we have Kaitlyn, an 8th grade student from Warren Junior High, and you ready to finally get to some work?
Yeah.
Did you know that there was even a possibility of working with bird eggs like that to manipulate them and things?
I think it might be possible, but I didn't really think it'd be successful at all.
Yeah, because I mean, I'm sure that it's probably been a lot of trial and error to get to this point.
Yeah.
But you're not working outside, you're working inside with babies. When you
Yeah.
get older, more towards the doctoring thing. We're going to need that also. You ready to work?
Yeah.
All right, over to the board. So this is some of the stuff that you're working on in class. So I'm going to give you a couple of random problems, and if you could explain to Cindy how to solve these, that'd be great.
Okay.
All right, here we go. Negative 2x minus 3y is equal to 10. And we need to solve for y.
Okay, so when you're going to solve for y, you have to isolate the y, which would be right here in the problem. So the first step would be to do inverse operations on the negative 2x to move it to the other side of the equation. And in that case, you would add 2x on both sides.
And then how do you know to start with that one and not the 3?
So if you were to start with the 3, that would kind of get kind of in the way because 3 and y are tied together in a way still because that's multiplication and this is subtraction. Or it would be subtraction. So then on this side, it would just be negative 3y now is equal to 10 plus 2x. Now we have the 3 or the yx isolated on one side of the problem, but we still have to get rid of the negative 3 on this side. And in order to get rid of that, you have to divide because that's multiplication there, so the inverse operation would be division. And you have to divide negative 3 off of that side as well. So then that would leave you with y is equal to 10 plus 2x over negative 3. And then you can move the negative 3 here, technically.
Yeah.
And
Well, if you moved it there,
yeah.
you want to put parentheses here.
Oh, that is true.
Yeah.
So then,
So you're saying the whole thing is negative and not just
Yeah.
like the 10 or
not just the 10, yeah.
All right, nicely done. All right, you ready for another one?
Sure.
All right, clear the board. You remember how to erase it all the way?
Like this, and then like that.
There you go. All right. X plus y over 5 is equal to 10. And this one I wanted you to do because a lot of younger students will look at it and go, I kind of got what you did, but now that the fraction is there, for some reason, it's making it more difficult.
Right.
So,
Fractions, no.
yeah.
So to start, you're gonna somewhat do the same thing, and we're gonna start with the x again. The reason why you would start with the x is because this is somehow bound together because this is a division, would be like represent division, but this has nothing tied to it basically. So this would be a positive x, and in order to do the inverse operation off of that, you would have to subtract x. And since you want to keep it equal, you have to subtract x from the other side as well. So that will leave you with y over 5 is equal to 10 minus x. And so you have to get rid of the 5 over here in order to keep y isolated. And in that way, you would multiply by 5 off of this side.
Yeah, and that's where kids would get stuck sometimes is they're like, what do I do with the 5? So since it's dividing, you multiply, so that's the inverse.
So you multiply by 5 on both sides. And so then that would be y is equal to 50 minus 5x.
And so just for the people watching, how'd you get from there to there?
So I distributed the 5 to both of the numbers. So 5 times 10, parentheses always mean to multiply. So 5 times 10 would be 50, and then 5 times negative x would be negative 5x.
Okay.
All right, you're 2/3 of the way done, young lady. Erase the board. I've got one more for you. So A equals C over 2, then in parentheses A plus B, and you are solving for A.
And then, if I recall, that's a capital A.
Yes.
Yes.
Oh.
Solving for A?
A,
Lowercase a?
lowercase.
Okay, so first I would get rid of what's inside the parentheses by dividing a plus b on both sides.
So which one are we solving for?
Oh,
No,
was
I'm just
solving-
asking you.
No,
Go
I was
ahead.
solving for the capital A.
Well, the capital A is already alone,
Or no, yeah, I was
so
solving
you're
for
solving
this
for
one.
that one, right?
Yeah, so that's wrong. That's the
I'm
harder
sure you
way,
could
though.
get it that way, it just might be
It's
more
just a
time consuming.
roundabout kind of way.
Yeah, it's not as
No.
efficient.
So then, in that case, distribute this first to both of these then. So that
So you
would be-
could, but can I help you make it a little more efficient?
Yeah,
So since A plus B is like grouped together,
yeah.
keep it like kind of like you said before, like 5 was grouped with X.
Mm-hmm.
Okay, so we're keeping this as a group. How can we get rid of this fraction that's not next to the group?
Okay, so then multiply that by 2 over c, right?
So multiply by the reciprocal, yeah.
And that would be, and then do that off of both sides. So that would be 2a is equal to, and then since those two cancel out, it would only be, well, would you still have to add that back? to
Well,
here?
so like since this is something times something, we're
Yeah.
just keeping that as a group times something. These can cross cancel here and here and
So
here
then
and
it's
here.
just going to be a plus b.
Yeah.
So then we still have to isolate the a. So then you would do just a reverse operation off of this, and that would be minus b off of both sides. So that would leave you with 2a over c minus b is equal to a, which can be written a is equal to the
Right.
other way as well.
I would maybe like circle. It just looks weird all bunched together. There we go. Now you can tell what part you answered.
All right, yeah, that's what we're doing right there. You've done some great work so far today. Do you remember one of the birds that we were talking about with Scott and Connie?
The condors.
The Condors, that's right. And for some great work so far today, you've got yourself a couple of tickets to go see the Bakersfield Condors, hockey team here in Bakersfield. Have you, oh, there you go, the Condor going apart. Do you know how big those wingspans are on Condors?
Big.
Yeah, they are big. If you had to put a number on it, what would you think? So this, I would say, is probably about 6 feet,
Yeah.
right?
Yeah.
Maybe a little more, right?
6 feet.
From here might be a yard or so, right? So how big do you think it would be? Bigger than this or less than this or equal to it?
Bigger.
How much bigger? Like, if this is 6,
That's 6. 12 times?
what if we did something like that? You think it'd be that big or even bigger?
Bigger.
Bigger. Probably, right? That would be 10 feet,
Oh.
the wingspan on a condor. But anyway, you'll go see the human condors at the Mechanics Bank. Is that it, John? No, the Mechanics Bank Arena right there. All right, you know what? Irregular shapes. You know what irregular shapes are?
Yeah.
Can you name any one? Probably not, because you're irregular shapes, right? We're going to check it out right now.
Hello, my name is Omar again, and today we're going to be solving the area of an irregular shape. An irregular shape is a shape that has different lengths and sizes. But to also find the area of an irregular shape, you have to separate the shape into simpler parts. Like for this example, you could do like this, or even add a part like this. But I am going to separate it right here, because it's much easier for me to do. But now we have a problem, because to find area, you have to first follow this formula, length times width, but we are missing our width. And to find our width, first you have to find the area of this the measurement of this shape, which is 8. And if we look at the other side, which is parallel to it, is 5. So if you drag your pencil to right here, this whole part is 5, which means to find the area of this shape, you have to subtract 8 minus 5, which will equal 3. So to find the area of this shape, you have to multiply 6 times 3, which will equal 18, which means the area of this entire shape will be 18 meters squared. Now I'm going to find the area of this shape, but since we are not missing no length, we just can multiply length times width, which will be 10 times 5, which will be 0, and this will be 5. So the area of this shape will be 50 meters squared. But to find the area of this whole entire shape, you have to add the two measurements, 50 and 18, which this will equal 8, and this will equal 6. So the area of this entire shape will be 68 meters squared. And this is how you find the area of an irregular figure.
There you go, a little Let's Talk Math with Omar right there, and how to find the area of some irregular shapes. That's pretty close to what you and I did at the beginning of the program, right? Mm-hmm. All right. 636-4357 is the phone number. We do have phone tutors available Tuesdays and Wednesdays throughout most of the school year. Phone in to do the math, and we are going to send you to the Kern County Fair today, as we are going to do right now with our first caller. Good afternoon, Emma. How are you?
Good.
And you're in 4th grade, correct?
Yes.
All right. Now, you are working on some different properties of mathematics. Is that what you're doing?
Yes.
All right. So why don't you read some of the problems to us, and Cindy's going to help you out, and if she needs some help, we've got Kaitlyn here also.
Some of the problems are complete each number sentence, identify the property or rule used.
Okay, so let's hear one of the number sentences.
One of the number sentences are 85 plus 0 equals 85 that I wrote down. And there's this big line at the bottom that I do not know what to put.
So there's a line where?
At the bottom of the question and the answer.
So are they asking you what property was being used? Was there anything that you had to fill in, or was it given to you as 85 plus 0 equals 85?
Says complete each number sentence.
Okay, so do you think that number sentence is complete right now?
Did you already complete the number sentence?
Yeah.
So you put the 85 at the answer part?
Mm-hmm.
So it said originally 85 plus 0 equals blank, and you filled it in with 85?
Yes.
Okay, and then underneath that there's another line that you need to probably put the property on?
Yeah.
Because it says and identify the property. Okay. So do you know the name of the property that says when you add 0 to a number, you still get the same number as your result?
Yes, I do know it, but I technically forgot it, and then it's in my notebook at the school, but I'm trying to remember it.
Okay, so let me see if I remember the name of the property.
We're just going to go with the 0 property.
Is it? I thought that was when you multiply by 0.
Well, it's going to work with this also because you're not adding anything
It's
to it, so
additive
it's
property
a 0.
or 0.
Right.
0 property of addition? I don't know. Does that sound familiar? 0 property?
Yeah, it's a 0 property, but it's like identity or something, I don't know, like identity.
Identity
So identity will be if you are doing...
like 7 equals 7.
Right, so this right here, so we've got commutative, but we're not moving anything.
Right.
Associative,
Distributed.
right? Distributive, you're not distributing anything.
Right.
And so we're going to go with 0 property on this one right now. Do you have another one of your number sentences that you were working with?
96 plus 13 equals 13 plus 96. Blank, the one at the 36 plus 96, blank 96 out, and I wrote 96.
All right, so let's try it again. So it's 96 plus 36?
Yes.
Oh, I thought you said 13.
I mean 96 plus 13
Okay.
Okay.
Is equal to,
is equal to 13 plus blank.
okay.
Okay. And you filled in the blank already?
Yeah, which was 96.
Okay. And then you need to identify the property because you forgot your notebook, yes? Correct?
Wait, did you say I brought it?
No, I said you forgot to bring it, right? It's at school still?
Yeah.
So the property that tells you you can change the order of the two numbers in an addition problem is called the commutative property. So this one's going to be that because all you did was change the order. So that's the commutative property.
Does that sound familiar, Emma?
Yes.
Okay, do you have another number sentence that you were working on?
The other sentence was 37 minus 0 equals blank.
So 37 minus 0.
I mean, blank minus
Oh.
0 equals 37.
Okay, so 37 minus blank
Blank
equals 37?
minus 0.
Yeah.
Like
it
that,
that way?
blank minus 0 equals 37?
Yes.
Okay. And then did you fill in the blank already?
Yes.
Okay, so what'd you put?
37.
All right.
Now, do you want to go with identity? I mean, because identity, nothing is changing. But I always,
I thought identity was just when it's like the number equals the number.
or if you're multiplying by 1, it's still
Is that
The
an
same thing.
identity property or is that the multiplicative
multiplicative.
property of?
But I don't want to go above what she's doing in 4th grade.
Yeah, I know. So do you remember, does the names of the properties sound familiar that we're talking about?
Yes.
So did you hear, when we said earlier the 0 property, do you remember that being one of your properties?
No.
Okay.
So what do you remember any, like on your paper, does it have any of them listed?
No.
So we're going to go identity then.
Okay. Because you get the identical number back.
Yes.
Let me see if I can get rid of that for you, Cindy, in a second.
I keep bumping it.
Well, we're just going to leave it like that for the moment. Does that help you out, Emma?
Yes.
All right. Do you have any other number sentences that you needed to work on today?
Yes. It says 15 plus 23 plus 7 equals 15 plus blank plus 7.
Okay. So 15 plus 23 plus 7 equals 15 plus blank plus 7.
The blank was 23.
Okay, but that was the correct, what I read was what you said, right?
Yes.
Okay, so the blank is 23.
Oh, it has some parentheses at the first and the last.
Okay, so in the very front, the very first part where they had all the numbers there, what two numbers were inside the parentheses?
The two numbers beside the parentheses were 15 plus 23 and 23 plus 7.
Okay, there we go. So when the parentheses move, but the numbers stay in the same order, you're regrouping. That's called the associative property. So this would be the associative property of addition, because it's an addition.
So why don't you just write out
problem.
associative for her so that
Yeah.
if she needs to write it down, she's got it. So Emma, if you need to, since you don't have your notes, hopefully, well, you're just hitting that board all over the place, aren't you, today?
Okay, I don't even know what I did.
I think you pulled the shade on it or something here. Let me,
Whoa.
oh, look at that.
That's
Wipe that right away for you.
Kaitlyn.
I'm nowhere near the board.
There's associative. All right, Emma, hopefully that helps you out. And for calling in today with some great problems, you got yourself a couple of tickets to the Kern County Fair, so congratulations on that. Hopefully you have an opportunity to go and have some fun out there, and who knows, maybe you see some dancing animals right there.
Okay.
All right, have a nice evening, Emma. Thanks for that phone call. Hey, you know what? We have another feature here on Do the Math, and this is one that we're very excited about. It is Culinary Calculations.
My name is Miriam Alqaisi. I own Radio Sandwich, and this is Culinary Calculations. Today we're going to be looking to find some inspiration for a new recipe, and what better place to start than at the farmer's market. Let's see what we can find. As you can see, they have some really pretty squash blossoms here that are distracting me a little bit. Now, if you look more closely at a squash blossom, you can see it has what we call five-fold symmetry. That means that if you split this flower in 5 different directions, it will be symmetrical. So if you cut this way, it'll be symmetrical. If you cut that way, it'll be symmetrical. This way, that way, and the other. All 5 directions, this flower will have symmetry, and that is why this has 5-fold symmetry. So since we're so enamored with this squash blossom, let's see what else we can pair with it and bring it into the kitchen. If I take this poblano pepper and I want to make squash blossom stuffed poblano peppers with tons of yummy cheese and gooey, crispy loveliness, I'm going to need to know how many poblanos and how many squash blossoms I need for one recipe. If we know that this particular recipe, each person gets 1 pepper, we know that we need 10 peppers for 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also know we're going to need quite a bit of squash blossoms for each person. Now, we got to keep in mind that this will wilt when we cook it. We're going to chop it finely, and it's going to wilt quite a bit. So, although they look large now, and it looks like maybe you'll only need 1 per person, you've got to remember that cooking creates a physical change as well as a chemical change, and this will change in size. So, I think we're going to need 2 squash blossoms per person. If I have 10 peppers, that means I need 20 squash blossoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So since this bundle has 11 squash blossoms in it, and I know I need 20, they're not selling these flowers individually, so we'll need to buy a second bundle. That's how we're going to scale up this recipe. And if we really want to be precise and count this and make sure we have enough squash blossom per pepper so there's no waste, we'll know that we will have an extra 2 squash blossoms here, which means that we can buy an extra pepper. Another thing that H&A Farms is known for is their berry selection. I see strawberries, blueberries, I see blackberries, and I see raspberries, but if you look closely, you can see something even more in this raspberry. You see all these different little seeds? Raspberry is a drupe fruit. Each one of these is a drupe. Comes apart to an individual unit. Now these units connect together to make a raspberry, and the way that they connect is following a pattern that I'm sure we've seen in other places. It's called the Fibonacci sequence. If you start at the bottom of this raspberry, you have 1 drupe, then you have another 1 drupe, then you have 2, then 3, 5, 8, 13, and on and on and on and on. Now the pattern that you're seeing is the 2 numbers previous adding to create the 3rd number. So 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 3 is 5, and so on. That pattern can be seen quite a bit in nature, and you can see it in this raspberry too. Now we're going to use these raspberries to make a really nice cheesecake ice cream. Now again, these raspberries will go through a physical and a chemical change, which means they will change in color, texture, and quantity. when we cook them down. So I'm gonna need quite a few of these little cartons to make enough syrup for one batch of ice cream. If this carton cooks down into 1/3 of a cup of syrup, and I need 1 cup of syrup, I'm going to need 3 different cartons of raspberries. And there we go, that's enough to make 1 batch of raspberry cheesecake ice cream. Okay, so I'm really happy that Vintage Farms here has got Kern honey on stock. We got a couple things to talk about with honey. Number 1, it's gonna be great in our raspberry cheesecake ice cream. Number 2, I noticed another pattern from nature. If you look closely at the label, it's got a print of honeycomb. Now, honeycomb shows another natural phenomenon, mathematical natural phenomenon, called tessellations. Tessellations are hexagonal shapes that interlock and can be found in quite a few different places in nature, the most obvious being honeycomb. Looking at this jar, I noticed something else. Is honey a liquid or a solid, do you think? Well, depending on how you measure, the answer could be either. If you look at this label though, they've taken the work out of it for us. They have liquid volume of 32 fluid ounces. Then they also have volume by weight of 47.8 ounces. So this is ounces and pounds, this is ounces, quarts, gallons, pints, etc. So depending on how I choose to bake with this, I may want to weigh it out, in which case this would tell me I have 47.8. I know I need 30 ounces by weight, so I know I have enough here. If I was judging by the volume, I would think I had much less than I do, because the liquid volume is 32 fluid ounces, and the weight, net weight, 47.8 ounces. Fluid ounces are volume measurements. So if I pour this into any other container that can measure out 32 fluid ounces, it'll be the same. Now, ounces by weight take into account density, which means that this jar may weigh differently than this jar if it was filled with water, for example. So this jar filled with water would be 32 fluid ounces and 32 ounces by weight, but because honey is denser, this may be 32 fluid ounces, but it's 47.8 ounces by weight. So we gotta make sure we're getting the right amount. Okay, so we've got our produce from our favorite vendors. Next time, we're gonna be in the kitchen playing. Why don't you join us and see what we do?
And many thanks to Miriam right there, once again, owner of Radio Sandwich and Culinary Connection right there, Calculation. Culinary Calculation, it's a connection also because that's food going on right there. And I know that Miriam makes some awesome food, and when I saw all of that, and I know that we're gonna be doing some raspberry ice cream next time, right? All right, big ding on that one, right? The camera guys are like, oh yeah, they're all set on that. In studio with us, we have Kaitlyn, an 8th grade student from Warren, and you are ready to do an absolutely wonderful problem right now. Are you ready? All right. Kaitlyn, tell me what you see on the board.
A 72 and a 46.
Or it could be a 7, a 2, a 4, and a 6. It doesn't have to be 72 and 46, does it?
Yeah, I guess so.
It could be. And I can move them around. It could be 7, 6, 4, 2.
Okay.
So you are able to move those numbers around. What I'd like you to do first of all is take in between the 2 and the 4, put an equal sign between the 2 and the 4. So does 72 equal 46?
No.
No. That's pretty straightforward to see. Is there any way that you can manipulate the numbers so that you will have an equal equation? An equation that works.
Can you flip numbers?
So if you want to, you can rewrite things down below. You can use your 2 fingers to move numbers if you want to drag them to different places. No other symbols can be used. So you can't use any addition, subtraction. The only symbol that's going to be used is that equal sign.
Okay.
Okay?
That's a question for him. He has the rules.
So there's a 6 right there, and if you flip it, it's a 9. Like if you flip it. Is that possible?
You want to flip numbers?
Yes. It's not adding
Fine,
another
if that's
sign.
what you want to do, flip it.
Okay.
I don't know how 72 is going to be 49, though.
So then in that case, it could be 7 squared is equal to 49, right?
So you're going to flip the 6 and make it a 9.
Yeah.
And you took the 2 and made it an exponent.
Yeah.
Did you help her with that?
No, I did not.
I
That's why I
thought
looked
I was
at her.
gonna give
She
you a
goes,
great problem.
I think I know. And I'm like, no.
You must have gained wisdom like this in your 6th grade gate class is the only thing I can imagine right there. You must have gotten things like that.
I wonder
on how to do
who.
these
I
things.
wonder who my teacher was. in
Yeah, I
sixth grade
wonder
game.
too. And you know what? In junior high, I'm sure your instructor has also helped you gain the insight into looking at things a little differently also. All right, hot shot, erase the
Shouldn't have
board.
showed her ahead of time.
That's pretty good though. So what was going through your mind when you saw that? Because you're like 72 does not equal 46. Because there are a lot of kids at home going, all right, well, I can understand it now that you flipped the 6, but what made you think about that instead of doing something different?
So
Was it something I said or something you thought? What was going on?
So I kind of just looked at it, and then I was like, there was no really like a way to get all the numbers to somehow like on either side using exponents or anything like that to equal each other. So then I was like, I knew you can use the 2 as like an exponent, like 2 to the power, or wait, a number to the power of 2 for any of the numbers. And you can also, but like if you were to use 2 to the power of, or when, that's not a good example, 6 to the power of 7, that would be a number that's way too high for 2 and a 4 to be equal to. So then I was like, I kind of just thought already that the 2 should be a power because there was going to be no other way, adding, subtracting, or anything.
Right,
And
you
then-
couldn't use any other
They'd be too
symbols.
big, yeah.
Right, you couldn't put
Yeah.
any symbols in there, so you had to use the numbers the way they were. But
Yeah.
that was pretty clever, thinking about the 6 and flipping it. It must have been because I wrote the 6 so that it looked like it could be flipped.
No, but it doesn't, because like if you flip that exactly,
I'm only messing
it would
with
be
you.
like it would look like this looking thingy.
Well, let's see. You know
Because
what?
you messed
Hold
up
on a
your
second.
6.
I'm going to see. Let's
so you
take
can
this,
grab it
and I'm going to flip it.
The green
Yeah,
one.
you just pull the green. That works too.
But that's a flip.
Except for you didn't.
You have to
Turn it the
then
other way.
flip
So
it.
now you want to turn it.
Yeah,
You have to
All right,
rotate
so now
it.
let's do this.
there we go. That's a 9.
You like that, huh, Johnny? It's pretty slick there, huh? There you go. So that's what you were thinking of.
Yeah.
All right, good. Erase the board. We've got more problems for you to do now. All right. So here's another one for you. S, capital S, equals n over 2, then in parentheses, a plus 1, close parentheses, and you want to solve for n. So if you could, please explain the way you did with Cindy earlier on the other problem.
Okay. So if you're solving for n, and since n is going to, like, n is could be distributed to a and 1, you kind of wouldn't want to do that because then you'd have a whole bunch of n's everywhere. So then instead, like, you should divide a plus 1 as a whole off
The whole group.
the whole, like the little grouping, yeah, to the other side of the problem as well. So that kind of transfers it to the other side of the problem. So then that will leave you with s a plus 1 is equal to n divided by 2. So then from there, you have to get the 2 like onto the other side. So then you can multiply by using the reciprocal by 2, because that cancels that right there. And then so then you multiply the 2 as well on the other side. So then that would leave you with 2s divided by a plus 1 is equal to n. And then you can write that n is equal to 2s divided by a plus 1 as well.
There you go. Nicely done. You've done some great work so far this afternoon. And does space fascinate you at all? Outer space? You ever think about something like that?
After like 5th grade gate and stuff like that, Mr. Shanor.
Oh, good,
He
because you
talked a
guys
lot about
studied a
it.
lot about space back
Yeah.
then. All right, well, you know what? We're going to check out what's new this week at NASA.
Tracking a mission's historic return to Earth, a year of science on board the space station, and the safe arrival of the station's newest resident astronaut. A few of the stories to tell you about this week at NASA. The return to Earth of OSIRIS-REx, our first ever asteroid sample return mission, is nearly complete. On September 24th, as the OREX spacecraft approaches Earth, it will release a capsule containing about 8.8 ounces of sample material collected from asteroid Bennu. Following a parachute-assisted landing in the Utah desert, the capsule will be retrieved and eventually shipped to our Johnson Space Center for examination in a pristine curation facility. The sample will be unveiled during a live televised NASA news conference on October 11th. September 21st marked a full year in space for NASA astronaut Frank Rubio. Since arriving at the International Space Station, he has worked on dozens of experiments. These include an experiment that grows tomatoes using water-based and air-based techniques rather than soil, an investigation that could enable in-space 3D printing of functional human organs for transplants, and more. Rubio is scheduled to return to Earth on September 27th after a U.S. record 371 days in space. On September 15th, NASA astronaut Laurel O'Hara and 2 cosmonauts safely arrived at the space station, increasing the number of residents aboard the station to 10. This 6-month stay on the orbital outpost is O'Hara's first spaceflight. In celebration of Hispanic Heritage Month, we are releasing new content for Universo Curioso de la NASA, the agency's first Spanish-language podcast. A 5-episode season kicked off on September 19th, with new episodes scheduled to be released weekly. For more about Universo Curioso de la NASA and other NASA podcasts, visit nasa.gov/podcasts. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/Tuan.
All right, and as a reminder, we do have phone tutors available on Tuesdays and Wednesdays for you. Kaitlyn, an 8th grade student at Warren, has been in studio with us today doing some great work. And is there anything that you have done in math throughout your 8 years in school that you have found like, well, that was kind of a challenge for me? It took me a long time to kind of get that.
Possibly like certain like math counts problems.
Okay, yeah, because math
regarding-
counts is a pretty difficult competition,
Yes.
right? And so you like that?
Yeah.
Oh, good. So are you doing that again this year?
Yeah, I most likely will.
Yeah, so you're certainly going to try for it, right?
Yeah.
And then I'm sure you're going to do well at it because you seem to be a very bright mathematical student. You like math?
Yeah.
Good. That's the important thing right there. You like being an ambassador? You know what an ambassador does?
Sell stuff.
Well, they can sell stuff, but you're not going to sell anything
Don't
for
they get
us.
paid though?
You're not getting paid either. You know what? You're going to let everybody know about the Do the Math program. Can you do that for us?
Yes, this
All right.
is
Well,
the
that
Do
will
the
be your
Math
uniform
shirt.
now, right?
Yes.
There you go. See, you got a uniform out of the deal. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.